So let me try this problem in a very just practical way. I won't necessarily rely on the graphical, numerical, or algebraic method. I'm just gonna get through this problem by putting my thoughts on this paper. So here's what I'm thinking. I know that x is approaching a very deep negative. So I'm thinking first at the denominator. If I plug a huge negative number in there, my denominator, the double negative, would knock out. So it would essentially be 2 times infinity. Now in here, when we're talking about the infinities, we essentially look at the strongest piece, which is this one here. So if I take negative infinity, square it, that's positive infinity squared, if you will. And then if that goes in there, that's negative infinity. But infinity squared minus infinity is still infinity squared. So stay with me here. This weaker piece, it sort of becomes irrelevant. And the negative infinity squared is infinity squared. But when you square root it, it goes back down to just infinity. You can put a 1 there, why not? And then in a sense, the infinities knock out in a sense, so it essentially just equals 1/2. So I did this in a very informal, sort of out loud type of way. And we can rely on Desmos to further convince ourselves. So here in box 1, I typed in the function. Now I have a point that is going to be tracing the function, this one here. Let me zoom out a little bit. So watch, we're approaching negative infinity, meaning moving to the left. And as I do so, look at the y coordinate of this point. You see the y coordinate, it looks like it's approaching something very specific. And that specific value for the y coordinate, that y coordinate that we're approaching is, of course, the same, positive 1/2. And look, it keeps going here more to the right. So you can see that the limit of this as x approaches negative infinity is in fact going to be positive 1/2. For this one here, this limit is actually going to be does not exist. And let's see why. So the 1/2 is just a distraction. There's a 1 here, there's a 2 there. That 1/2 can be pulled out to the front. Properties of limits. I'm left with x over sine of x. Now, if the problem said sine of x over x, that would be something else entirely different. That's not what it says. It says this. And here, as x approaches negative infinity, well, that number is just going to be a really deep negative. But here, that's an issue because the sine of negative infinity is not defined because recall sine. Sine is a function that just goes like this. And as we're approaching negative infinity, we are not approaching a value in particular. We're just going up and down forever and ever and ever. So plugging negative infinity into here, this part alone, that part alone, the limit would not exist. And you can even see here on the graph of x over 2 sine x, as we move to the left forever, it's a pretty cool looking graph, but as we move to the left forever, we are not approaching anything in particular because in one instance, the y coordinates are going up, but they're also going down. So we're confused. What's happening as we move to the left? Is the graph going up or is it going down? It's doing both. So for that reason, I would say that the limit does not exist.